have a topic on the managerial economics, right? And it's for level 300 students. So the very topic on the managerial economics which we're going to treat is production in the short and long run, with some practical tutorial examples for us to comprehend the concepts. At the end of each session, my counsel will be that you will practice most of these questions for familiarity with the content. Alright, so we're going to have here, let me use man-econs for the course, right? So looking at the course. Then we're going to discuss production. Okay, we're going to discuss production. So basically, let's first start with the factors of production. Factors of production. What are the factors of production? We can have a comprehension of what is called sale. Sale, where we talk about capital, we talk about entrepreneur, right? So, entrepreneur, we talk about land, we talk about labor. Okay, so there are other factors affecting production. We can talk about materials, but basically we are looking at only these four factors. Now, in terms of our course or the topic under this course, we are only going to concentrate on capital, which will represent by a K, and labor, which will represent by an L. We will also say K and L are what we call inputs. Okay, so production, we are looking at trying to produce. So basically we are talking about outputs. What will be the outcome after we have our inputs in place? That's the output. So we are looking at capital and labor factors affecting production. That the input factors are capital and labor basically. We're going to use this to solve several questions in a production functional situation. So the production here, whilst we are looking at capital and labor as inputs, we are also going to represent production, that's the output, by the alphabet K. So we are going to look at the factors which affects output, that is the factors of capital and labor that affect output. So these two, capital and labor, are what we are trying to look at as how inputs affecting the output. So output is a function of capital and labor factors. Alright. Now we will proceed to look at some variations under production. Now we can say that production is made in the short run and in the long run. Okay, so when do we determine when the production is in the short run? Production is in the short run when one input is fixed, whereas the other input is variable. So in the short run, we say that one input, how many inputs are you talking about? We are talking about capital and labor in this circumstance. And one of them must be fixed in the short run, whereas the other must be variable. So basically, in the short run, that is the short run, right? In the short run, capital is fixed and labor is variable. So when you ask, how can you determine whether a production situation is in the short run? You must say that one capital which is an input is fixed. So usually the capital will be in units to be fixed. And then labor to be units to be fixed, to be variable. Okay, so in the short run, capital is fixed, units. Labor is variable, units. Okay, so what if we have what is called the long run? In the long run, all inputs are variable. When you say variability, you are referring to the fact that labor units will keep changing in the long run. So for example, with respect to the short run, when I'm going to set up a business, so I rent a premises for about 1 year. That is my first cost. The 1 year rent is my first cost for the term or the tenor where I'm going to have my business. So that 1 year is my first cost. So that being my first cost, my labor cost for all the laborers or employees I'm going to employ will be my variable cost. So that's a short run. But so a short run is not determined mainly by like an accounting within a year, no, but it could even be 6 months, a short run. It could even be 8 months, 3 months. Now the long run is a period where all the inputs comprising capital and labor are variable. So basically, if I should say that I'm going to rent a place for 2 years, let's say for 1 year I pay. The cost of rent is fixed for a year, but it is subject to renewal after every year or annually. So at the end of 1 year, I'm going to change my rent cost. If I'm going to either pay higher or lower. In that case, in the long run, input of capital is variable as well as labor. So we say it's variable. Alright, so we also have to talk about some few variations. When we talk about what is called marginal product of labor, marginal product of labor. So marginal products of labor, which is represented by MPL, we say the word marginal is additional unit, right? So if we have if we add one more labor, what will be our output? That's basically what it's trying to say. Marginal product of labor. If we add one more labor, what will be our output? Now the formula for the marginal product of labor is defined by saying that change in TP over, this is an L, so change in L. We assume there is a T after the M, so marginal total product. A marginal means a change that's additional. You must have an initial before you can have an additional and have a carry. So change in TP, which will also be given by, when we change the TP to output, change in kill equals change in labor. The outputs, kill, and the total products are the same. Now, we will mainly use this kind of formula when we are dealing with a tabular form. Let me say a tabular form where we have levels. So we can have a table of labor output. We will say when labor is 0, what was our output? 0. When labor was 1, our output was 5. When labor was 8, our labor equals 2, our output was 7. That is when we will use this approach. Then, when we come to calculus, that is, if we are trying to solve it in an equational form, we use the MPL equals the change in its delta, it will change to derivative. So dk over dl. That is when we are dealing with calculus or an equation or a function. So these are just intros. We will use these two for our calculus, but mainly the very practical question we will solve from the tutorial question falls within the calculus approach. Then we also look at what is called marginal product of capital. The same process. Change in total product over change in capital, because there's a K here. So change in total product over change in the capital, change in total product over change in labor. Then we're going to say change in quantity over change in K. It's also used for a tabular form. Then we have the MPK, which goes with it. When we are dealing with calculus or an equation or function, we're going to say dk over what? dk for an equation or function. Now, we're also going to talk about average product of labor, which equals, there's a T here, to total product over labor. We're going to say average product of capital, total product over capital, or average product of labor equals output over labor, average product of capital equals what? Output over capital. These are variants of the production equation we are looking at. Now, we'll also be looking at, we've looked at the short run, we've looked at the long run, we've looked at all these equations. We'll also be looking at what is called total costs. by the function TC. Now we are looking at what is called isocost. In the isocost concept, we are not actually applying the actual formula for total cost, which involves fixed cost plus variable cost per unit. We are not applying this rule. Alright? So in this very concept, we are going to look at how the cost of capital, right, is multiplied by the capital units plus the wage, which is multiplied by the labor units. But to say more about this, let's say that rent, R equals rent equals rates equals cost or price of capital, right, equals price of K. So we're going to use these variables interchangeably depending on the requirements of the question. So we have R, which I will see probably often, equals rent slash rate equals cost or price of capital equals PK. So the PK can represent any of these here. Then we have the wage to be equal to the wage equals the cost or price of labor, which is equal to PL. So this price of labor is price of capital. We're going to use this interchangeably mainly during the moment of our computations, right? To try to define the optimal levels the firm should produce, right? And the combination of the capital unit and unit to be used. So the total cost function, you're not going to use this very usual variable cost per unit plus fixed cost. We're going to apply the rule of the isocost, where we're going to only look at adding the variable costs together to constitute the total cost of production. Here, already we've explained the K and the L, which are units. So capital units, labor units. But the R is the rent or the rate or the cost of the price of the capital, which is the PK. Then the wage is the wage or the cost or price of labor or the PL. So we can also write the formula in another way, saying TC equals PK times K plus PL times L. This is another form we can write it. Just substituting PK with the R and the PL with the W. Okay, so let us go to our last theory, then we start with some few calculations. So now our next step from the total cost, the total isocost which we discussed, we'll go to what I would refer to as the optimal levels. Optimal levels, right? What are the optimal levels? In the firm, in the business, the main focus of the firm is to maximize profits, maximize revenue, maximize outputs, right? So basically, the firm is interested in maximizing this. When you say optimal levels, the best level the firm can produce, right, or function. The firm can function at maximum profit. Another concept is we think about minimum. So the firm would minimize costs. If you're a business, you have to actually think about minimizing costs. You minimize costs, any cost, whether marginal costs, you try to minimize customer costs. So in the equation we're going to solve for, we are going to be told to find profit, the optimal levels. So when we are in the short run, isocost, where we're going to only look at adding the variable costs together to constitute the total cost of production. Here, already we've explained the K and the L, which are units. So capital units, labor units. But the R is the rent or the rate or the cost of the price of the capital, which is the PK. Then the wage is the wage or the cost or price of labor or the PL. So we can also write the formula in another way, saying TC equals PK times K plus PL times L. This is another form we can write it. Just substituting PK with the R and the PL with the W. Okay, so let us go to our last theory, then we start with some few calculations. Alright, so now our next step from the total cost, the total ISO costs, which we discussed, you go to what I would refer to as the optimal levels. Optimal levels, right? What are the optimal levels? In a firm, in a business, the main focus of the firm is to maximize profits, maximize revenue, maximize outputs, right? So basically, the firm is interested in maximizing this. When you say optimal levels, the best level the firm can produce, right, or function. The firm can function at maximum profit. Another concept is we think about minimum. So the firm will minimize costs. If you're a business, you have to actually think about minimizing costs. You minimize costs, any cost, whether marginal costs, you try to minimize customer costs. So in the equation I'm going to solve for, we are going to be told to find profit, the optimal levels. So when we are in the short run, optimal levels, in the short run, maximum, in the short run, we will say that VMPL equals W, or VMPL equals, what did we say W represented? W is the same as what? PL. So equals what? PL. So the first question is, whenever you're solving production questions, after understanding the question, you ask yourself two basic questions, or a very basic question. Is the firm operating in the short run or in the long run? That's the first question, before you attempt solving anything. So here you are saying that in the event you realize that the production of the organization or the firm is being done in the short run, this is our optimal level, maximum. So whether at maximum or at minimum, we are going to deal with at maximum or at minimum. This is our equation which we are going to settle on. Now, this VMPL is value of, or value marginal product of labor, where in essence the value represents the price. The one relation between the value and NPL, they are multiplied. So value times what? NPL is equal to what? PL. Or value times the NPL is equal to what? The wage. So at maximum or at the optimal level, it's a maximum profit, revenue, or output. This is the first you have to deal with when the production is in the short run. Right? So the price and the NPL equals the wage, or the price and the NPL equals the PL. That is what we go. But first, we have to say the value marginal product of labor. The value marginal product of labor is also called marginal benefits or marginal revenue. So in some cases, you could say that VMP is equal to the MR, alright, the marginal revenue. Okay, in some cases. So that's when it's in the short run. If you ascertain that the production is in the short run, then you have to determine the maximum profit, revenue, or output, or the minimum costs. We have to first take the short run maximization function before we start solving. Short run 2. In the long run, at maximum or minimum, we say that marginal rate of technical substitution equals MPL over what? LPK equals what? Wage times R. Or marginal rate of technical substitution equals MPL over MPK equals, what is the wage? PL, what is the rate? PK, that's the rate. Right? So in the long run, we're going to ascertain whether it's maximum or minimum in the long run. This is the formula we're going to use. In the short run, if you ascertain that the production price is in the short run, this is what we're going to use. In the long run, that is what we're going to use. Okay? So our first duty is to ensure that our first is to ensure that we ascertain the period in which, or the timeline in which the production function is being taken place, or going to take place, right? And now we've learned how to find MPL, marginal product of labor, in terms of a function using calculus, and marginal product of capital in terms of a function using calculus. Alright, so basically, these are the major things we need to learn about. Okay, there are graphs which we have to do, but the graphs will be done later on. But currently, we are going to pick a practical question and we will solve that. Alright, so we're going to start with a practical question, and I'm reading. It's from question 15C from the document I have. Okay, so I'm first reading it. Sorry. You are a manager for Herman Miller, a major manufacturer of office furniture. You recently hired an economist to work with engineering and operations experts to estimate the production function for a particular line of office chairs. Right? The report from these experts indicates that the relevant production function is Q equals 2K 0.5 L 0.5. That's the production function we have. Where K represents capital, equipment, and L is labor. So in this question, the capital is not accounted capital. What are you talking about? Funding of a business, but here it's about the assets to run a business. Let's say basically equipment, machinery, plants. Alright? They constitute capital we are referring to. Okay? And L is labor. Your company has already spent a total of $9,000 on the 9 units of capital equipment it owns. Due to current economic conditions, the company does not have the flexibility needed to acquire additional equipment. Workers at the firm are paid a competitive wage of $100 per day, and chairs can be sold for $500 each. The first question is the firm operating in the short run or long run? Explain. So from what I just read through, even the question even asks you whether it's operating in the short run or long run, you must first identify, ascertain for yourself whether or not it's producing in the short and long run before you can start solving it. If you're not able to ascertain it, you cannot start solving it because you didn't know which of the optimal levels to use. You cannot assume a long run production function, right, will be substituted by a short run production function. It's wrong. Or a short run optimal level. So your ability to ascertain which states, which time period the production function is being carried out is the first class, or is the first incentive to keep you going to get the right answers. So in this question, how do we know whether it's in the short run or a long run? So let's reread it again so that we can pick out the key point. Don't forget how to determine when it's a short run. In the short run, one input, which is usually the capital, is fixed. The other input is labor is variable. In the long run, all inputs, capital, labor are all variable. And we said the capital and labor are represented by units, not the amount, units. So you're a manager for Herman Miller, a major manufacturer of office furniture. You recently hired an economist to work with an engineering and operations expert to estimate the production function for a particular line of office chairs. The report from these experts indicates that the relevant production function is this. Now, your company has already spent a total of what? 9,000. Let's write them out. 9,000. So how much your company spent is how much it costed the company. So we'll say that the TC is what? $9,000. And then on the 9 units of capital equipment, remember capital, the K represents the units, not the amount. So this K is the capital, which is what? 9 units. I write out my key terms for my calculation. It owns, due to current economic conditions, the company does not have the flexibility needed to acquire additional equipment. Workers at the firm are paid a competitive wage of how much? $100. So here they use wage, which is $100 per day, and chairs can be sold for $400 each. So the price of the chairs is the cost of the chairs, right? How much they are selling, the selling price. So price is equal to what? $400 each. Now, how do you know? The first question is that, is the firm operating in the short run or long run? Explain. How do you know? The same concept. In the short run, one input must be fetched. In other words, they must give a value for that input. So in this case, since how many inputs are you talking about? Capital and labor. Here we say that capital has been given. Specific unit of what? 9. Therefore, we will say that in the short, this production firm is operating in the short run. Why? Because the units, a value for capital has been given as what? 9. So, is the firm operating the short run or the long run? The firm is operating in the short run. This is because capital units is 9, which is fixed. And in the short run of production, one input into bracket capital must be fixed, and the other inputs must be variable. So it's very brief. Is the firm operating in the short run or long run? The firm is operating in the short run. This is because capital units is 9, which is fixed, and in the short run of production, one input into the capital must be fixed, and the other input must be variable. That is very simple. So always you'll be looking out for, did they give any units for capital? Then it's going to be fixed. It's going to be short run. If there were no units given for capital, then they will not give any units for labor. That's basically what we are trying to do here. Now, the question 2 says, what is your profit maximizer level of what? Output and labor usage. So, profit maximizer level of output and what? Labor usage. So, just look at what we are trying to say. What is the profit? Now, we determine that it's the short run. 1. The second question is to find the profit maximizer level. So, if the maximizer level is set as an optimal level, as I said, profits can be maximized, revenue can be maximized, output can be maximized. So, if you are looking at the profit and it's maximized, what should be the equation? Again, are you going to use long run or short run? You are going to use short run. Short run because the firm is producing in the short run. So we say in the short run at maximum, what do we say? Value marginal product of labor equals what? The wage. Where the value marginal product of labor is the same as the price times marginal product of labor equals what? The wage. Right? Where price, so the question, where price equals $400, wage equals $100. So we know, since we are solving for the maximum value, right? We know the value for price to be 100. We know wage to be 100, or we know price to be 400. Do we know NPL? We don't know the NPL. Do we know the wage? The wage is $100, so we have 100. So what are we going to find? We're going to find the NPL and bring it back into the equation and find the value we're looking for. Therefore, we will say that from the formula above here, you would say 400 times the MPL equals, what is the weight? 100. Then I have to find the unknown, which is the MPL. Therefore, the MPL will be equal to, remember the formula we did when it's calculus, dK over dL. dQ over dL is the marginal product of labor. Now, when we come to derivatives or differentiation, and we are differentiating the K with the same as the total product, which means that referring to the original equation, refer to the original equation and differentiate. I will refer to the original equation and differentiate. However, before we can differentiate the K, we must plug in the K, which equals 9, into the function to reduce it to have only L so that we can differentiate. So let us go and plug the K into the K. So before we can differentiate this, we say Q equals 2K 0.5 L 0.5, where K equals 9. Where K equals 9. So, where we're going to have Q equals 2. What is the K value? Where K is 9, 0.5 L. What is the L? 0.5. This is what we have. So, we're going to have Q equals, now, we should pay attention here. Don't multiply the 2 by the 9 to get 18 and make it 8 less than 0.5. No. Alright? These two has its own exponent, which is 1. Then 9 has an exponent, which is 0.5. L has an exponent, which is what? 0.5. So, we don't multiply 2 and 9 together. You rather find the exponent, you repeat your 2, and find the exponent of 9, which is the 2 exponent 0.5, which will give us 3. Then your L 0.5. So now you can multiply both together because they all have the same exponents, 1 and 1. So 2, 3, 6, L 0.5. Having reduced the original function, reduction function, to have only L as an input by replacing it with the constant 9, we now can find our MPL. So we would say MPL equals what? dQ/dL. So now it says, go to differentiate equation Q or function Q with respect to L. That is the variable L. So to differentiate it, we'll do this. We apply the law of differentiation. We multiply the exponent by the coefficient of the variable that differentiated. So 0.5 times 6. What do we have? Let me now say 0.5 times 6. Then L. Then we subtract 1 from the exponent. So 0.5 minus what? 1. Therefore, MPL equals dQ/dL equals 0.5 times 6 will give us also 3. Also give us 3. They are going to have L negative 0.5. So basically, because I want to comprehend, I have to break this down. But ordinarily, if I'm to solve, I'll skip this whole step and just write this there because I multiply. So 0.5 times 6 is 3. Then 1 minus 0.5 minus 1 is negative 0.5. For those who have forgotten a bit about differentiation, just a recap. When I have a figure like a squared, let me say 2q, and I'm to differentiate, let's say this is y equals 2a, y equals 2a cubed. If I'm to differentiate with respect to a, it will be multiplied 3 times 2, which is 3 times 2. Then your a, subtract 1 from the exponent, so 3 minus 1. So dy dA will be equal to 326 a 3 minus 1, 2. This is called the derivative or the differential. That's the same concept we are trying to apply here. So, having gotten my MPL, which is over here, I now come back and write 400 times, what is this, my MPL? 3L less than 0.5 equals 100. That's it. Then, since these two are multiplying together, I multiply this by this. I'm going to have 3 by 4, I'm going to have 1,200. L negative 0.5 equals 100. And to make L the surplus, remember the question was that profit maximizes level of output and labor usage. It doesn't matter whether labor precedes output. All that is, if I'm to find one, I must first find the bar to help me find the other one, which is the output. And I'm working at maximum. What is the evidence? I have equated the maximum short one function. So I'm still within the scope. Now, what do we do next? Since I'm solving for L, and L is being sandwiched by 1,200 with an exponent of negative 0.5, I have to divide both sides by 1,200, 1,200 to get rid of the coefficient. So I'm going to have L exponent negative 0.5 equals what? 100 over 1,200, which will give me 1 over 12.